Hello. A decent amount has happened since my last stream, even though it's only been a day or two. I went ahead and implemented some more instrumentation for performance metrics. They're a lot more accurate and granular than they were before. So first of all, you can see running in non-verbose, you're getting time spent lexing down to microseconds, time spent parsing, time spent in metaprograms, and time spent generating code. These four categories now mean what they actually mean in a way that they didn't before. So lexing is purely the time spent anytime we spend time in the lexer, which I'm still not sure if that's exactly what I want to do, because the metaprogram, for example, when it goes to output code, it calls into the lexer. So the metaprogram calling into the lexer counts toward this time, not time spent in metaprograms. So for now, it means exactly what it means. Time spent parsing is the amount of time we are spending parsing lexers. Time spent in metaprograms is obviously any time that we are spending running metaprograms, and generating code is two things, which you'll see in a second. It's both generating the string and also writing the file. So obviously you can see that's where it takes most of our time right now. But now if I do verbose, you can really see it broken down very specifically. So if you ask for verbose, you get time spent lexing is the same, right? Time spent parsing is now broken up into core and post. So there's the core part of parsing, which is your just your code being parsed. So the lexer looks at your source files, generates a list of tokens. That is then handed to the parser to make sense of those tokens. Post is, there's a post pass that happens that does all of the second level things of like, and actually I can just show you what that is. If I go to post pass, it's like updating function calls if they're actually macros or snippets. It's actually doing the replacement of, if I call a snippet, what actually replaces it in the tree. It's connecting types and declarefs to each other, function templates, struct templates, all the stuff that is not just like understanding tokens. Yeah. So that's our post pass. Both of these are on the order of microseconds. It's even in debug mode, these things are like blazingly fast. Now here, time spent in metaprograms, I break it down into each pass. So the way it works is you have your base code, we do the parsing on it, then we run the metaprograms on that. And those metaprograms are broken up into what I call default, which are the stuff that like is kind of central to the system, kind of, and then user or whatever metaprograms you want to write that you can inject after. So the results of these metaprograms could make new nodes on the tree, and so long as metaprograms have made new nodes on the tree, we do another pass on those. So then whatever nodes this pass generated, we run the metaprogram on those nodes. And then if that generated nodes, we run it again. Again, we keep doing it until we're out of nodes. So in here, there's two passes. Time spent generating code here. And if you're curious what these two passes are, I then break it down into the files that got generated. So we only spend, again, microseconds doing dependency mapping. Then the actual code gen. So here's the final file, which is the final output file. This primary pass generated this primary chunk, and then we run these things on the primary chunk. That's what this secondary pass is. This ended up not generating any code. So that's why there's only a primary chunk. There would be secondary chunk files here if it generated more code. So this is taking 2 seconds right now in debug mode, and that's just because generating the actual code, like generating the strings, is taking a long time. I would like to see this number go down. Because that's where most of the time in this is taking right now. This metaprogramming time is going to come way down because that's what we're going to do tonight, is implement some caching so these metaprograms don't have to loop over the whole tree anytime they want to query it. That's what's going to happen next. And this is, again, unoptimized. So if this is the optimized build, you can see it is substantially faster. You compile the metaprogram, and now that the metaprogram is compiled in release mode, which you normally do, it's optimized. When you run it again, all it has to do is run the metaprogram. It doesn't have to recompile it every time. So, lexing isn't really that much faster. Lexing is already just, it's really fast, so is parsing. Parsing is actually down, like, by half. The post pass especially got a big boost. The metaprograms are down by like a third. Again, that's going to come way down. Was able to cut the code gen over half in optimized builds. So this is still large. I'm not a fan of this number, but I haven't even really thought about ways to speed that up right now. Right now I'm really focusing on the metaprograms because as the metaprograms grow, pretty much every metaprogram wants to loop over the tree, and right now that is just painfully slow. So that's what is going to hopefully get a lot faster tonight. So I think what I'm going to do is let's take these numbers in, I guess, unoptimized build, and let's put them up somewhere so I can see. File timing. Okay, let's do this. Let's take this output here. Just take the whole thing, stick it in here. So at the end, we can see how big of a speed up we got. You can't see this. You will be able to see this later, but we'll call this before and after. Let's see how much faster we can get this. Okay. And if it doesn't get any faster, that'll be sad, but I can't imagine that happening. So, here's the thing that is so slow. These gnarly macros here. So, for each node of type, what this is doing is, if you're in the metaprogram, you want to see what are all my structs in the whole program, right? You're going to want to call this. What are all my function calls? Whatever it is. Metaprograms do that a lot. That's kind of their bread and butter. And right now, every single one of these is calling out to get nodes of type, which is this here, which calls get nodes of type recurse, which is right here. It is literally every single time looping over every single node in the entire tree, filling out this struct here every single time. Anytime anybody, so even here in this post pass, we do it twice, back to back. Even just right here, the post pass is doing it twice. And that's for every run of the metaprogram, or every run of the parser. This is bad. This is bad. So the way we're going to address this is we are going to, in fact, I have a giant to do here about performance, and my initial plan was to not have to like return this struct and all this stuff, but I don't think we have to worry about any of that. I think literally what we can do is just cache we'll call this like AST node cache, and we'll say each one, well, I was gonna say, do we even have to do that? I don't think so. I don't even think we need this as like a struct. I think this can just live in the parser. Like under the AST. This can be an array of nodes. So node cache. And the number of them will be however many types we have. So it'll be this count. So we have count of them, right? And trying to think what would be better. A linked list of nodes or an array of, or a linked list of node pointers or an array of node pointers. Just a flat array. I feel like an array would obviously be faster, but you can remove nodes from the tree. We do that in a few places actually. And for maintenance, a linked list, a doubly linked list would be faster. I actually don't know. That's actually a tough one. Because I could say, like right here, I could just say, well, and an array also means we're limited. We have to choose a size. So you know what? We're going to do a linked list. We're going to say node cache list. And this is going to be a node, and is going to see a metagen cache list node, and this will be next. And you know what? We'll have a previous as well. Doubly linked, so that way we can easily remove stuff. And yeah, so then this is going to be metagen cache list node cache. Doubly linked list of node pointers dispatched by type. Okay. So the idea here is you should be able to query this node cache and you pass it, or you index it by the node type that you're looking for. And we won't have to touch every single node in the tree. We can just dispatch straight to the corresponding list and just go through those. Make sense? Makes sense. So, I think we can get started. So, first things first, we need to build up these caches. So, let's say add defer node to compound statement. Let's see. Any place where we add, so add node to program, insert copy after. So let's see. Add node to program. Is there a better way to accomplish the above end without a global AST parser or pointer? Refactor these files with this util. Okay. Okay. We need to find all the places where nodes get appended to the tree. So let's start simple, just in the parser. I'm kind of jumping the gun a little bit. I went into the metaprogramming stuff. Create node, create child node. There's two ways to think about this. We can be maintaining this list kind of as we go. As things get added to the tree, we add them to this list. If I had known I'd be doing this early on and had thought about it. Hello. Diminished. How goes it? We're just over here thinking out loud. Two ways to go about this. What are you working on? We are working on a metaprogramming system language thing. So what started out as kind of like a C++ parser that I could add metaprogramming stuff to is kind of morphed into my own like little language project, I guess. So you can see like you can define functions, but you can have like parameterized types and it'll generate functions for you. You can tag stuff and then you can write metaprograms that so you can literally see I'm just generating an entire AST here that you can write metaprograms in C to modify, and then it spits it out as C code. And right now specifically, I added some extra timing, like some performance timings and stuff, and right now the time spent in the metaprograms are way too long given how small they are right now, and it's because of anytime anything wants to query the tree, it is doing a full loop and touching every single node, which I know is slow, but I just would come back to it later. Well, now's the time where I'm coming back to it. So thinking about how we want to cache nodes on the tree to make these queries almost free. Trying to think of how we want to do that. So that's what we're doing tonight. I'm also kind of working on a language, although I'm just starting. You're clearly much farther along than me. So yeah, I started this. What is my first commit? Actually, let's look over here. My first commit, October 13th of last year. So yeah, a little over a year I've been working on this. And again, started out as just a C parser, but then it's like, well, now that I have that working, I can kind of add whatever I want to it. So it has, like I said, morphed into this other thing. So the problem right now is I think anytime we call add child node, I think we can assume that this thing is going on the tree. I think. I guess we can go ahead with that assumption and then see if we have any duplicates or things that don't belong. Yep, that's pretty much how my project started, although in a bit of a roundabout way. I started writing a config file type spec, and now I'm writing a language backend of sorts. It's exciting work, isn't it? Dude, it is, I'm having a blast. Like, right now if I run this, like the code that you're seeing here, like right now I'm just outputting a few things, right? But like the things I'm outputting right now are, like, here's a U8, and I'm calling test func on it. Well, test func can take any type, right? And what this thing is doing is this $sign is saying what type is this thing. So it's declaring a new variable x whose type is whatever type I passed it, and whose value is the value of the thing I passed it, and then it prints it out, right? You can use ellipses for a variable number of arguments, and you can loop over them with this for any keyword I added. And you can see I can output the final file with no line number, so you can see what code it's generating. So like, here's that version of test func that is over here. It generated one that takes a U8, and it did that because I called it with a U8, right? And just within the last like week, we have concatenation working too. So in place of like C macros, I have these snippets that are, they're like macros, but they are parsed into a tree. They're not just like a textual replacement. They're actually parsed code. And we added these concat nodes to them, so yeah, just like concatenation in C macros, only they are in these snippets. So yeah, this snippet is actually like, if you call a snippet, that triggers the metaprogram to be like, okay, let's go replace these let's make a copy of it, replace these parameters, parse this as a tree, and then it sticks the actual tree into the AST at the call site, basically. And yeah, I'm just like, I'm having so much fun. Like, theoretically, this is supposed to be me like going and building another like cross-platform library and like game engine and stuff that I want to be doing, but I keep finding new things I want to add to this metaprogramming system, so I am it's taking me a while. I'm on the lexer part, although this is the second iteration, and the first was up to a parser. I didn't like how the project was progressing though, and the Git log was so bad since I didn't really understand Git. I chose to learn Git and then restart using lessons I learned from the first one. That is, I heavily relate to that. Out of all the time I've spent programming, I have probably restarted my game engine from scratch probably 5 times, and each time it's substantially better than the last time. And this is actually the second or third iteration of like my metaprogramming ambitions. This is the first time I'm actually like full on generating an AST and like doing it the real way, you know. But yeah, that type of iteration I am very familiar with. So good on you though. It sounds like you said it's exciting. I find it just to be a blast. So I'm having a good time. Okay, let's create node. Does that put it on the tree? No. Create child node does. Well, it appends it to something. So let's say parser node cat. We're a lot alike then, because this is sprouted from a game engine I had an idea for. I started 2 times but didn't like a feature in C99, so I started a C extension and it's evolved or devolved into this. Yep. That is very much how I feel about things. I don't know if you follow like Handmade Hero or if you've ever heard of it, but if you can't tell, this is not only is my like editor here, but also my general coding style is very informed by that series. And I don't really even use any C++ features. This is ostensibly C++, but I'm really only using operator and function overloading and the occasional constructor destructor. Everything else is pretty much pure C. So yeah. Okay, let's create a new function and call this add node to cache, and we're gonna just give it the node, the parser, and the node. And all this is gonna do is if parser node cache, let's get the type out of this because we're gonna need it. If there isn't any yet, we'll do one thing, otherwise we'll do another thing. So this will be the first entry. This needs appended to the end. Although my lexer will be much simpler than yours, I don't follow a Handmade Hero, but I'm familiar with it. I'm working on the back end right now, so it's a mix of assembly and C. Mostly C, but that's just to generate assembly. That is really cool. I mean, I already give you props for wanting to write a lexer and like doing that whole thing for your config format instead of just what started as a config format, instead of just like going with, I don't know, JSON or something. I already give you props for that. I find that stuff very fun. So and like actually writing a lexer and doing that kind of stuff is fun. So okay, so this will be the first entry. Let's pull up the definition for this. And I started streaming my progress on here just because I was excited about it, maybe like 5 or 6 months ago. I'm trying to do it a lot more often though, so I appreciate the follow. That's always nice to see more like-minded people. Toml is great, but not perfect, so I wanted to fix it, like any good programmer does. Yeah, that is the, I don't know about you, but I also find that once I start doing stuff like this, once I started doing this, I realize how, like, I'm just like one guy, and this is like a year-long project part-time, right? Because I have a full-time job. It's really not that hard to do some really cool stuff. And it kind of just makes me disappointed in like other offerings, you know? I don't know. I mean, whatever. People have different constraints and stuff. Like, this isn't... What I'm building here isn't necessarily, like, production ready or anything. But, you know, it's not nothing. Okay, so parser node cache type is, let's push type. This is going to be a metagen dude cache node. Okay. And we will just fill this out with stuff. The node is this node. The previous, well, I guess that's already zeroed, so that's fine. Those are both 0, that's fine. Then, if it needs to be appended, so I guess we can always do this. Always create one. And then we can say, we'll grab one of these and just say this one, or new. A lot of people will look at what we're doing and say, well, why would you do that and just use the tools and deal with the limits? But they don't understand that the fun in it for us is the optimization of processes. We'll get around the engines or whatever, but right now we're having fun on these projects. Yeah, I always find, speaking of Handmade Hero, Casey, who runs that stream, always had a really good thing that he would say is, people always would ask him, like, why are you reinventing the wheel? And his response is always like, that's assuming that the stuff we have out there right now is equivalent to the wheel in terms of their just like perfection and most optimal way of solving that problem. Like, to assume that we have the wheel in any of this is very presumptive. And I think we need people exploring the boundaries and stuff. Or even just like doing stuff themselves, and maybe they discover new things along the way, you know? Okay, this can be new, and actually this can also just go here. First entry. So I guess we don't have to do anything if it's the first entry. Right? This is actually fine. Oh, I guess I need the last one, right? There already exists stuff in this list. Find the last one. End. Oh. Wait. No, I'm doing this wrong. This needs to be, this needs to be new. And then, okay, we do need this actually. Duh. So, say this is the first entry. So if it's the first entry, then I can say parser node cache type equals new, right? It's just the head node. Otherwise, we have to find the end. So node cache type while end and, or while end next end equals end next. So we find the last one, and then end next equals new, new previous equals end. There we go. That will give us the appending to the list. So then when we create a child node, we will say add node to cache, and let's put a to do here. We can actually early out here on duplication, right? While we traverse to and just compare the node pointers. So I think we can just do that to avoid duplication entirely. So let's see. I think that's all we have to do. So parser and the result. Okay. So let's add child node. This is another add child node. But this is node. So actually, let's just look at every time we call push type with a parser node. Push type arena metagen parser node. Okay, it's literally those two spots. Wait. Oh, it's just create node. That's where we do it. And then we also do it in so why do we not call create node here? Because all that's doing is creating that type and line number, type. Okay, I don't know why we're not calling that here. That's weird. AST statement compound. Next line. Okay, so add child node still works. God, I'm a little toasty. I'm going to turn the AC on. Okay. So, I guess that's the only place we call that, which is good. So, anytime we add a child node, we should be adding to the cache now. And we didn't crash, so let's go to here and let's just check out our cache. Type index is 0, type index is less than AST, what do I call this? AST count, that's a weird name. I'll call this node type count. So for each one, let's just grab, let's do a print node cache. Pass it a parser. So here we will just print node cache parser. For each type, head is, or we'll say current is parser, node cache, type, not type index, just type. I don't know if you have to cast those. I'm going to do it anyway, though. Don't know if that's the kind of thing you have to cast. I don't remember. So if we have one at all, then or while we have one, I think we can just print node nicely current true, and then cur equals cur next, and then we will do that. Node type count, right? Now to replace that in different places, node AST count. Right. Hello. I can't type tonight. Okay. This is current node. And then parser was not declared. Oh, it's gotta be in here. In which case, actually, this can be result. Okay. Okay, I don't know why there are so many empty spaces in here. Oh. I'm probably including comments and stuff that I don't need to be including, so let's if type we'll say this. We'll say and actually I don't know why I'm doing that there. That doesn't make any sense. If type equals okay. Root we don't care about. Unknown we don't care about. We'll just do a whole bunch of them. So root, or I mean unknown, no op, root. Those are all fine. Operators are fine. Preprocs are fine. Wait, we're not including those. Hold on. End of stream. So we said root, no op, unknown. Continue. So why, again, why are we getting, it's fine. Why are we getting all these empty spaces? Let's print out the type. And actually, instead of this, let's just do this. Make token string, or not token string. No, it's not token string. It's I can't do that. I have to do parser node type strings current type. Node type. Yeah, why are we getting... Oh. Because if we print out if we didn't get any as well. How do I... I'll just say if not cur. Continue. There we go. Okay. I can get rid of this now. And instead do a... like that. Okay. And this can just be type. Okay. So now we can look at all these. Compound statements have nothing to print, so that's why those are just a bunch of empty things. But here we go. Here's our source file. Here's all of our variable decals. I need this to be like that. I mean, so that's pretty much our cache, right? Up front anyway. This does not include stuff that the metaprogram generates, but here's all of the decal variables in our program. I'm not sure what these are, because these... Okay, I'm not sure what these are. I'll have to investigate why. Because variables are a name with a type. Name. Okay. Let's print the line number. Because I'm not sure why that's happening. Line number. Okay. So these are all on line 33. Let's see what those are. Oh, these are our externals. It thinks those are variables. I mean, this one is, right? Oh, and these are, but they're parameters, right? Wait, char int char. So int char int. Int char int. I'm a little confused. Why? Why these are showing up under variable and not under like param and stuff like that? Why are they all variables? Oh, I probably don't. hold on. This might be a problem. Decal param. Crap. I don't add them to the tree with that type. I recognize that and add it later. I set their type later. That's no good. So I wonder if I should do what I was going to do initially. Instead of caching them as I go, when we're done parsing, I just do one big loop and cache them that way. And then anytime there are more nodes that got added, I will just do that. I'll invalidate the old one and do it again. That means that we are looping over the tree entirely for every run of metaprogram. Which kind of goes against why I wanted to do this in the first place. Well, I mean, not entirely. Because then subsequent metaprograms who can call it as many times as they want and they're using the cache. But arg. So I'm saying variable decal node here, parse variable decal. Why can't I pass this? I know it's going to be a param, right? Well, okay, hold on. Wouldn't our context here be equals AST decal param? Yeah, we only ever set it here. So I should be able to know, either I pass it into this, or I look at the context of what we're parsing. And I almost wonder if this should be passed in. So decal type okay, and let's just see how that breaks. This is context. This is all context. Okay. Let's just see what that does. That's gonna break things, but that's fine. We're in the middle of breaking things, so. Oh. I must have a AST decal param. So I don't need that anymore. but parse function or variable decal, parse function or variable decal. So this needs a type, decal type, function or variable decal. This calls parse variable decal. This will be an AST decal variable. Okay. There we go. Now do we have parameters? So we still work. Do we have parameters separated now? We do. So here's all our specifically parameters. Here are all of our specifically variables. So that's good. That's great, actually. So the problem is we have a lot of cases where we do that kind of thing. So if I go down here, here are all the places where I might do that for variables. I parse them as a regular variable and then, although I must not be because I changed that function signature and we don't fail. So parse struct, for example. How do we parse members here? Right. Parse function or variable decal. So that's happening here. Do we have a context that we're passing in? We do. I mean, so I could say this, decal type. We will say, assume it is a, oops, decal type. Assume it is a variable, but if context is struct, then our type is a struct member. Does that give us struct members? Yes. So now we've further differentiated structs, params, normal variables. I should ignore things that are in snippets, though. Which I think I can say by if node if is in snippet what do we call this? Inside snippet tree? Does that work from in the parser? I don't know. No. Oh, actually, we have a different way to do this in the parser. We say if parsing snippet where do we do that? This whole to-do we did. That doesn't need to be there anymore. Snip. If I go to do parse, parsing snippet is what I'm looking for. If parser parsing snippet, then return. So did that remove? Yes. So any of those concat variables, snippets are kind of removed from a lot of these processes. You can generate snippets from the metaprogram, but the snippets themselves do not show up. Well, at the moment, because I haven't had time to sit down and think about it, snippets are kind of separate from all the metagen stuff. Let's only doing this because I don't want to think about it. Seems like something we could support. Let's just see if we can catch if end equals end node equals node, right output found duplicate node. So let's see if we actually find any of those. And we shouldn't, and we don't. So that's actually good. That's really good news, because that means, at least when it comes to our parser, we are being good citizens and not doing like any weird duplicate info. But, so I will leave this in. You know what, I'll have this be a warning. And let me make sure my warnings still work. It's been a long time since, yeah, there we go. So, so we have warnings if that ever happens. So that's great. Okay. So that's good. So now add child node. Let's just look at all the places we do this. For literals, they already have they will already have the type, I think. Yes. For initializer lists, I think they will. Well, let's see. Parse expression. Parse initializer list. It does, right? Create node. It automatically has the type. Bro, type, please. C style cast. Try parse C style cast. Cast node. Okay, it already does. Param node. Those are just expressions, so that's fine. parse a cast. A lot of this is going to come down to parse expression, honestly. I'm going to try and get this assembly generator done in a month. Super unrealistic, but I want to have something to work on when I start my classes. I find setting deadlines like that for myself really good. It helps me a lot. What classes are you taking? I assume you're in college? Create Unity pre. So that already has it. That already has it. That already has it. Those have it. Those have it. Those have it. Ternary nodes all have it. Okay. Okay. That's good. That has it. Parse struct should have it. Which it does. Parse anonymous struct decal. Right, that's fine. Okay. That should all be fine. Struct node, that's all fine. Oh, parse function decal. We create it with the tag. So I'm super old, but I've decided to go back to school for a degree to get into the field that kind of requires one. A field that kind of requires one. But because I'm starting out at the beginning, I'm already a bit ahead of the class, so I want to have something to work on in classes while the instructor is explaining variable types to the others. Cool. I'm 33. I've been programming since I was like 11 or 12 probably. When I started college, well, there's a longer story there that I won't go into, but when I started taking my computer classes, I was very similar. Especially early on. A lot of that stuff, like, basically didn't have to attend the classes. So I know how that feels. Well, good luck, and I hope you can find ways to entertain yourself and you can get some work done in those times. Struct node. So what is this? Those are the members. Okay, we passed that. Great. Oh, but here we go. We set them here. We need to not be doing that. That's where we get into trouble. So function or variable decal, when we do this, I'll be 28 soon. I started with C++ and Unreal, and that just wasn't doing it for me. Well, I do look forward to helping the others. I do enjoy teaching and helping, but I'll need something else to do during the lesson. It's so funny because the thing I wasn't going to go into was it took me 8 years to get my bachelor's because I started at a community college where the CS classes didn't transfer. So I switched my major to physics. I really should have been in CS the whole time. And then by the time I was a couple years into my physics degree, the university I went to had a non-existent physics department pretty much. So I eventually switched finally and had to basically start my degree over. But I actually worked as a tutor for how long was I there? I was a tutor for 2 or 3 years, I think. Theoretically, I could tutor physics, but I was really there to just help people through their computer science classes. So I would not want to go into teaching, but I loved tutoring. Let the teachers deal with the actual like classroom, but I am totally down to go help people. So I want to specialize in computational physics, so I think we have much in common. That's really cool. That is computers are fast, man, and the idea that we can apply them to problems like that, I do think is super cool. Where did I put that thing? Here. We'll do the same thing here. We'll do the decal type once again. We'll say AST decal function. Struct function. And then parse function decal will also take a type, a decal type. And this will take that. And then every time we see this, it'll be decal type. Crap. I don't want to go into teaching either. I want to do research. I mean, that's cool. That's definitely... I always find... I knew a lot of teachers who were there to teach, quote unquote, because they were the teachers, but they really just like... the schools gave them the opportunity to do their research stuff, you know? I feel like that's relatively common. Okay, crap. This is annoying because I guess we'll just do this. 0. And then we'll say here. This is really dumb, but I'm doing it this way. Ooh. Oh. Otherwise, we can just do this. Decal type. And this is decal type. This is decal type. We'll also say decal type equals that. Decal type equals that. I'll definitely consider it. I'm not very active on stuff like that. So it's not a specific no because I'm like super private or anything like that. I just don't really use that stuff that much. But I will definitely keep in mind you might see an invite from me if I do. I do admit that it's not super common to find, especially when it comes to like computer programming stuff. Finding like-minded people can be hard. Let's see. So this can be decal type. This can be decal type. Decal type. Okay. So I think that's good. function decal. Oh, that was a typo. Parse function. Okay, now, so 2042. Inline constructor. Yep, I hear you. Like I said, it's like you mentioned before, nothing personal. I will I'll definitely consider it. That sounds really weird, but surely you understand. What am I doing? Parse function decal. What am I forgetting here? Where did I change that before? So it takes the decal type, which is just there. So here, this is in parse function or variable decal. If it's a decal struct and we have a node and it's the name. Oh, inline constructor. Okay, yes. So here I can just say that's fine. Okay. Parse function decal, that's fine. This is just an AST decal function. This is a AST decal struct destructor. Parse function decal. Decal type, I guess. This is parse. If get token next and crap. This is going to be I think that gets handled. I think that's fine. Okay. I missed one. 2508. Oh, this can just be that. Okay, struct. Let's see if we grab those correctly. Let's have a templated constructor and a destructor and see if those get picked up. Struct underscore, there we go. They don't have names. They probably should, They should probably get the name of the thing. Which, wait, they don't. Even though I'm saying they should. That's weird. That should have a name tied to it. Let's just print out. Wait, this is print token. I mean, there you go. There's the token, templated. It should have gotten the name. Set node name. There you go. So why am I not seeing it? Print node nicely. Oh. No, I'm doing it. Get name from. This is confusing. Because we're not getting either of these, actually. Why not? Let's see. Let's go back to the parser. Struct constructor. Oh, oops. Struct constructor. Create node. Set node name. Parse function decal. Oh, wait, the constructor name is the previous token, so back up one. Yeah. There we go. Hello. Why is that happening? wonder if I'm doing this. Oh. These are in line, actually. Aha. Well, no, because that's still going through this. Right? We're still calling parse function decal. So I don't understand. Let's actually debug this, because I don't know what else to really do there. So let's go to print and if cur node type equals ast decal struct constructor. So only do that there. Actually, let's how about we do if type does not equal ast decal struct constructor. So we'll only print out them for now, because that's all I'm interested in. Why is it empty? Let's find out. Okay, let's go all the way down here. And here. Don't need this, or this, or this, or this. I just deleted my... Why did I not break? What is happening? Oh, it's running. Wait, what? Oh. Well, that'll tell you. I'm not using debug and release anymore. I'm using unoptimized and optimized. So that was a older executable. There we go. Okay, let's look at current node. It's a destructor, which means it's a decal function. There we go. It's got a name. It does have a name and a line number. There's the line number. Print node nicely. I'm a dummy. Print node nicely. Notice how I literally looked at this and said, look, we're printing it out. We're not. For these two, we are not. We are very specifically not. And in fact, let's not have these be the same thing, because for these, we want to do everything except the return type. Okay, let's copy this whole thing. And we don't want any of that. Still want that. And we'll say if should I include the tilde in the name of the destructor? I kind of feel like I should. Although, then when you're searching for destructors and you want to type match it, if it's destructor specific. Well, so I'm thinking like in here, you'll see a list of constructors and they'll just be all the type names. Destructors will be similar. It'll just be a list of type names. But should it be a list of type names preceded by tildes? Because the only thing that really does is then in the metaprogram, if you're searching for destructors of a specific type, you have to remember when you're finding them to be like, is the type name equal to tilde thing? Or I can leave it as is and just print the thing here. Right? I can just print it. I can append it there. Which means, let's get rid of this. Not type, what is that called? Node type. Hello, dumb guy codes. I like your name. I am working on a metaprogramming lexer parser system that right now spits out C code that then gets compiled. So it's kind of like my own mini metaprogramming language. Started as a C parser and then is now... I can show you an example of that actually, what it does. Okay, so here, I'm just appending this tilde to the destructor here when you print it, but if you search for destructors and look at their names, they will not have that on them. I'm not sure what to do about that, but to answer your question, what does it do? So a quick example of that is, let me turn off this giant print that I'm doing. So whenever you're building your program, it always runs this metaprogram first. And what the metaprogram does is... Hi, Diminish. Yeah, I'm on YouTube and Twitch. So I can tell it to print out the tree so you can see what it's doing. It is taking my whole program here. So like here's my main. I have some functions that do some special stuff. I have some structs, stuff like that. It generates an entire syntax tree of it and then passes that syntax tree to metaprograms that you can write, which are just C functions that can iterate over this tree and manipulate it. And then at the end, it spits out, once you're done doing all the manipulation, it spits out a it spits out this giant C file, turning that tree back into code. But because you're able to manipulate that tree in C, you can do all sorts of stuff like, oh, I can loop over all the structs in my program. I can like loop over all the structs in my program and spit out functions for them, or I can generate new structs based on... But you basically have a bunch of data about your code and then can spit out more code intelligently. So if it makes you feel better, I'm trying to figure out how to do abstract stupid on... How to abstract stupid on 4 different levels. Am I AI? I hope not. Maybe I'll find that out someday. And we'll be very shocked. Okay, where are we? What just happened? Okay, I just rose my hand and blinked twice to appease YouTube chat that I'm not an AI. Hopefully it worked. It was good enough for me. Okay. So I think that worked just fine. If I turn that back on, I am in fact not AI. This is in-I, non-existent intelligence. Okay, so you know what? It makes sense. That destructor's name is tilde name of struct. I feel bad faking it. You know? That feels bad in my soul. It feels like I'm lying about what this thing is, so let's not do that. Let's add it to the name. Why channel is dead? You mean like my YouTube channel? If you're wondering about that, it's because I used to do, if you know what Gary's Mod is, I used to make add-ons in Gary's Mod that were actually pretty popular, and my channel grew a lot. And then after I started school and kind of did some other stuff, I totally just let the channel kind of die out. So most of those viewers are just like ghost ancient viewers or ancient subscribers. So that was back when I was like 16, 17, 18. I'm 33 now. So that was a while ago. It was half a lifetime ago. Even. You can still find all those videos on my channel if you just go back. Okay, let's go to the parser and actually give these things a... So when I set node name here, I will actually set this to... we'll say destruct name. It will be this plus get token text next. Let's not lie about what these are. There we go. Do I have to do that anywhere else? No. Okay, I feel better about that. Decision made. It's okay, man. You keep doing everything. You'll be fine one day. No, I'm not that worried about it. It's more just like, do I wish I had kept up with it that whole time? Would I have a pretty decent following now? Yes, but, you know, it happens. I learned a lot in that time. I like who I am now, so... Is it assembly language? This is not assembly language. This, the parser itself is C++, and the language I'm making is basically a modified version of C++. So... Okay, great. Now all I have to do is in the metaprograms, right, in CodeGen here, whenever we add to the tree, making a language, holy crazy. Yeah, it started out as just wanting to parse C code, like C++, and do metaprogramming with that. But once I built the parser, I realized I could add other stuff to it. So I just started doing that, and now it's kind of morphed into my own language. So that's why you see like these tags or like this $any, stuff like that. That's all stuff that's part of my language that's now, it's not really C code anymore. So I think if I go to run metaprograms internal, or no, we want remaining nodes. Here we go. So here's where we run the metaprograms on the remaining. So if any nodes got generated by one pass of the metaprogram, they get added to this queue. And then all at once, any nodes in the queue, the metaprograms get ran on those, which may add more to the queue. And it just keeps doing that until we've iterated enough that there are no more... The last metaprogram generated no new code. And once we're there, we know we're done. So every time we do one of these chunks, I almost wonder... Here we go, append child. I think we can just do this here. You know, I think we can just, in append child... I just Googled, you are manipulating the other programs, crazy man. Yeah, I am. I'm writing I'm writing programs that write programs is what's happening. Yeah, pretty much. I'm just a dumb guy who is smart using AI. I mean, if it gets you thinking about coding and like doing stuff like that, you know, no shade. You know, if you're having fun doing it, I really can't say anything about it. So I just enjoy doing this stuff. So append child, right? So append child. Oh, that's also calling create node. It's just not doing it on the parser. Though I can understand your code, I don't know why. Well, I will say, a lot of this coding style I adopted from this internet series called Handmade Hero, if you don't know what that is. And this style tends to be a little more verbose, a little more like normal English than you might be used to seeing. So that's why there's just a lot of intercapsed full English words. So it can be a little easier to read than some other code bases. Reads almost like English. So this is where I take this secondary chunk is another source file, right? So I think here, where else do I call append child? The metaprogram does. What does add node to program do? Does that just add it to the queue? Output AST. Man, see, this is why this gets really tricky once you have just metaprograms doing whatever they want to do. If they are not going through my normal functions to do this stuff, I cannot reliably have a up-to-date cache that accurately reflects the state of the program. The only way around that is, instead of doing what I'm doing and adding them as I go, every iteration of the metaprogram, I just do the whole thing. I just loop through the entire AST and cache everything there, which I really don't like. So maybe I save this next part. Now that I have the cache building part, maybe I save this next part for next time and figure out, rewrite a lot of this metaprogram stuff to follow very specific conventions. Because even like here, we're just setting these names willy-nilly. This really needs to go through that set node name function. Which we only introduced last time. So these metaprograms are like out of spec, basically. Why is thumbnail like that? The thumbnail is actually a screenshot from a game that I released a few years ago, called Superposition. I have it linked on my Twitch channel, but I don't really have it linked on YouTube. You can go to my YouTube channel and find it, but I can also just link it here in the chat. Hashtag ad. Yeah, that's a game I put out a couple years ago. That is my primary interest. He says, wow, you are a game dev too. That's my primary interest. That ultimately, I do have plans to use this metaprogramming stuff for all sorts of things, but one of those things will be another game engine that's powered by the metaprogramming stuff. That's like one of my goals here. So that game, though, Superposition, is on my previous game engine, which has none of this meta stuff in it at all. You are crazy, man. Well, I take that as a compliment. I appreciate it. Do you use AI to do stuffs? No. Well, I will occasionally use it to ask certain very specific questions. If it's like, how does this Windows API work or something? But no, none of the code you're seeing here is coming from AI at all. I've been programming for like 20 years now, so I've been doing it a while. So I appreciate your interest though, and your hyperbolic but kind words. Okay. I mostly just need to understand how these things are working. Because this adds it to the queue, the generation queue, which I think is what we're using. Yeah, that's what we're using here to run the metaprograms on. I think this is what I need to do. I need to loop over this chunk. So this is going to be kind of a hybrid thing. The metaprograms are unwieldy enough that I don't want to have to try to catch every time they add something to the tree. So I can just wait till they're done. And before I stick, or when I stick that tree onto our tree, I can do a loop over just that tree and add those. I think that sounds reasonable. Although, are they ever adding? Yeah, they can be generating. I thought they might be having to generate source code that we parse anyway, but no, they can actually just straight up insert nodes on the tree. So AI is decent for research if you're having a hard time finding things, but it's not very useful for much else in my case. I totally agree with that, at least in terms of the actual code that it writes. Unless you're doing simpler things, I find it's not super useful for code gen stuff. I will say, so at my day job, I do like FreeBSD driver stuff, like networking cards and stuff that need to work, integrating new driver drops and stuff. And I am not a FreeBSD expert by any means, and trying to find that information online, that documentation just doesn't exist. If you want to know, like, this Chelsea driver has these receive queues in it, and I want to know how this one specific part of it works, you're never going to find that anywhere. But AI that's been trained on FreeBSD code, I can totally ask it stuff like that and it gives me good answers. So that's how I actually use the AI stuff in my day-to-day, is for stuff like that. And I actually find it, like, in some cases a lifesaver. You still have to go vet the information, obviously, but it's for stuff like that, it's super, super helpful. Okay, so this actually I don't think will be that hard. So we can literally just say cache this tree, or how about just cache tree this secondary chunk. How about that? And we will say we already are deduping this. Void cache tree. This needs a better name. How about add tree to cache? And we'll pass it the parser, and we'll pass it a root of a tree. Okay, so for each child node of root, add node to, I think this is all we have to do, parser child, and then add, or we'll do this, we'll say add the root to the cache, and for each child, add the child. I actually think that's all we have to do. Exactly, I can ask the AI I'm looking for a function that does this, or where I can find this in the BSD source, and it can just point you in the direction. Super helpful for that. I found so many definitions that way. Yeah, totally. That's where I find it to be kind of magical, actually, because it can, like, truly behave as, like, a documentation wiki on FreeBSD, for example. And, like, it's the kind of thing that, like I said, that documentation just doesn't exist. You'd have to stare at the code for like a month to even start to understand some of that stuff. And it can just explain it to you. It's been super helpful for that. Okay, that might actually be it. We can just add, we're kind of being lazy about that, but for each child node that's not declared, so because that doesn't exist here. How about we just move this over here then? How about that? We'll just move this to CodeGen because I don't care. Child.node is what this is. I need to pass the parser in here. Does this also need it? Yes, it does. Okay. Well, there you go. I'm still not convinced that we're not missing anything, which is honestly scary. I need to write a sanity check that counts all the nodes in the tree and then counts all the nodes in our cache and verifies that they're the same. I will write that to do right now. And we will make it so you cannot miss it, because this is very important. I would say that if you enjoy debugging, it's the perfect tool too, because it's great for providing bugs, although I guess I am too, to be fair. That's a good point also. That's why I still don't trust any tool that will like insert code for you, or you ask it to generate code and it just kind of starts manhandling things. I can't say that I'm into that. And again, no shade thrown on people who like vibe coding and stuff, but it's definitely not my thing. Okay, there's that. So the next thing I want to do really quick is let's replace this macro and see what we get. So we'll say for each node of type in tree, get nodes of type. Get nodes of type. So we're gonna say if 0, so these are gonna be the slow ones. Fast, slow. So let's take these. So this is going to do is, for each child node, instead what we're going to do is okay. Wait, we're not even recursing anymore, so that's not even the right thing. This is not the right thing. These are the thing. So, slow. Okay, here's the functions we're actually replacing. This makes more sense. Okay, get nodes of type. Instead of this, we are going to say we're going to get the cache. If I don't know what it's doing, it doesn't get added. And if people developing the AI claim they don't know what it's doing, it's not going into my project. Yep. And I can at least say, even at my job, that is true company-wide, is they are, and everyone else I know who's in software. Well, I guess I don't know people at some of the biggest places, but everyone I know who is not at the biggest of the big places say that it's mandated that they are not shipping code that comes straight out of AIs. So, at least not yet. I imagine that will change at some point. Okay. So, we need to get metagen cache list node. Current is these need the parser. Or do I have a global parser? I guess I do. That's not good. I forgot about this. We actually call this on individual ASTs. Ooh, I didn't think about that. Because you might call this on a certain specific scope. This is actually fine. It should still be faster. We're going to say node belongs to tree. And we'll say node tree, root. We'll say tree. Okay. How about AST? be consistent. So, given, okay, let's just assume we have that. So we're gonna say current is global parser node cache of node type. If not current, return result. And then, or I guess we don't have to do that. This can just be while current equals current next. So if there's nothing, it's going to be empty. That's fine. So and actually, if I'm doing it this way, we don't need the previous. Actually, we do, because we need to be, that's something I haven't done yet, is I need to handle the removal case, but we'll get there. My nose is itchy tonight. So, the node is current node. If node belongs to AST, node AST, then we will, what is this doing? This. Node indices equals wait, what? Oh, that's its index in the parent. What do I use that for? Node indices. Current dot index. Okay, I don't remember why we're keeping the index. But we do. And I'm too tired right now to try to understand why we're doing that, but I need that. Let's have it give us back. No, let's have it give us back child index. Node child index of node. So we can say index. We'll do this. We'll have this be signed. Well, we only get an index back if it is a child, so we know that'll be a good value. So now all we have to do is write this function that says, A, I'm part of this tree, and B, what index am I? So results, we're going to say is false, and then while parent equals node parent, while parent, if parent equals AST, result equals true, and we can break. And then otherwise, parent equals parents, parent. Okay. So there's that. But then we have to get our index. Do we have a get child index? Bro, look at me already writing this. Look at me already having this function ready to go. Child index of node equals get child index. Oh. You know what? I don't have to do this weird thing. I can literally just do this. Get child index. Node. Yeah? I think so. Okay. Then let's copy this and do the same thing here, but this function you ask for not just a single type, you're asking for multiple types. So you can query multiple at once, which is a number of types and then each type. So all we have to do here is the same thing, but this will go in a for loop. Type index equals 0. Type index is less than node types dot num types plus type index. And then this is node types dot types type index. Yeah. So if the metaprogram still works, that'll be kind of a miracle. Dest was not declared. You're right. There is no dest. This is result dot. This is result dot. More result dot. Get child index was not declared because it's got to come higher up because C++. Okay. Well, something happened. Let's stop printing out this giant thing. So encounter an unexpected note. So we are printing out, or we are spitting out a C file still. Whether that's it's clearly not a good C file, but we are getting one. So we've got, what is the actual problem? Main, conflicting declaration of main. True. We have a for decal with no parameters. Interesting. I didn't break something else, did I? Let's slow. Let's turn slow back on. No, we're still working. So, so right now I don't actually know. Oop, God, I keep bumping the mic. Sorry about that. I don't actually know if what's broken is the loop I just wrote, right? Like, I don't know if these functions are broken or if the cache is incomplete, you know? So and it is getting late, so I don't really feel like debugging this right now. But now that it's in here, theoretically, once this is, whatever bug is causing this stuff, unexpected node type. Can we can actually print the tree right now? No, the tree should be fine. There's nothing wrong with the tree. What's wrong is its ability to loop through these things. Know what we can do? Let's write output node. Let's print out the type and print out how many we got. Okay. Anytime we query for nodes, we'll print out how many we got. Okay. And we'll do that if it's non-zero. Right, so we are definitely getting things, right? But now let's compare some of these. Do we actually have 6 functions? Right, dash T. We will grep for decal function. Ooh, and actually, if you look at this, we see the function number going up every time we call it. That's interesting. And let's count the lines. 41. Wait, what? Oh. Let's count it with this. Arg. 12. Okay, so we have 12 function decals. That is counting the snippet, though. Oh, and it is grabbing all these new ones from... These are being generated by the metaprogram. All these get type info pointers. The metaprogram is generating those. Which I think may explain our That may explain our... Oh, it's right there. Our 1, 2, 3, 4, 5, 6, 7. Although we shouldn't be seeing this number change from 6 well, actually that's not true, because this isn't necessarily being called globally. Yeah, okay, this is going to be a little more finicky than I initially thought, which is fine. This should net a huge speed increase. My need for a config format has arisen again. I guess December will be for config file. Hell yeah. I definitely will be curious how that goes. Scope might be a little different, but in spirit it doesn't seem all that dissimilar to what we're doing here, so... Okay, so even though we're not actually properly doing the metaprograms right now, I just want to see what the speed difference looks like between the slow and the fast. So if I turn on slow, so fast, we are at 26.5 milliseconds, which seems like it's actually already a lot faster. Yeah, I mean, we cut that down to a quarter, almost. I'm destined to make config file parsers for my whole life or until I actually do it. I know the feeling. Okay, so that actually cut it down immensely. I mean, obviously it's broken. It's not actually doing what it's supposed to be doing right now. But it's still outputting code. Like, it's still doing stuff. So I think we can at least say that it's at least comparable to probably what we expect the gains to be. If I run this optimized, we're under 10 milliseconds on the metaprograms. And we cut down generation. How did we cut down generation? That confuses me. I'm not sure how we're cutting that down so much. But things are also broken right now, so I can't even say for sure that that's accurate. So metaprograms were 8 milliseconds in that case. And in this case, they were 32. Yeah, I can't celebrate yet. I can't trust these numbers. So, what I will say, though, is it's late, and this next part is... Writing this was the fun stuff of like, hey, let's cache things and use the cache. Now that we have to actually verify that stuff works, I think my brain is too tired to continue. So let me give myself some good to-dos. That's another nice thing about streaming, is I actually totally refer to previous streams to be like, where did I leave off? What was I doing? To do next time. And today is the 2nd. We're gonna say currently trying to use the cache fast mode if def is failing. We actually compile and run just fine, but the what is actually erroring? What actually is the error here? Unoptimized. The error is in... Is that in... Yeah, that's in code gen. Okay. We hit an error during code gen. Too tired to debug tonight. Okay. Good enough for me. I just realized my first config attempt I wrote in comment logic. Why? Who needs comments in a config file? I actually don't mind. I really like having comments. Pretty much, I get annoyed actually if I'm writing in some language, even if it's just like a small config format and I can't put comments in it. Only because like I feel like they are relatively straightforward to ignore when you're parsing, but I guess it also depends on what exactly how this config file works. If it's literally like descriptive variable name equals descriptive value, you probably don't need that much explaining. I could see that. I always slouch so much by the end of these streams. It's actually really bad. They're not when I really like the C-style single line comments. You mean they're harder to parse when they're single line like that? They just have so many edge cases. Yeah, I ended up for my parser, I don't know how yours is working, but my lexer I'm calling this skip white space everywhere, right? Anytime I'm done lexing or parsing something, I call this skip white space all the time. But what skip whitespace does is, while skipping through quote-unquote white space, it is looking for the comma, or the comment signifier. So the lexer really isn't looking for comments. When it skips white space, comments get picked up during that process, which takes care of comments at the end of a line, comments on their own line, all that kind of stuff. And then since the lexer just picks them up, they are just tokens in the token stream. And the parser then, when it's chewing through tokens, when you ask for the next token, if the next token is a comment, it just skips it and gives you the one after that. So on both sides, they're kind of invisible, if that made sense. Working is a generous term applicable only on every other Thursday and full moons. Dude, I spent 2 months not working on this. And that's because I started down a path that really sucked and I was never happy with. And then finally, a couple weeks ago, I'm like, this is stupid. I'm throwing this out and starting over and doing it a lot simpler, which I have done over the last 2 or 3 weeks. And I'm much happier, and now I'm back to working on it every night because I'm like excited about it again. So that's huge for me personally, is just being excited and first and foremost happy with what it is I'm doing and how I'm doing it. If I'm not happy with the way things are going, it really demoralizes me. So, yeah. I think, though, that's going to do it for me tonight. I'm very close. I have a cache sort of, I think, kind of working. I need to verify it and then get this part working. But early, broken, I can't really trust it numbers are promising. So Git has made the process so much easier because throwing away a branch is easier than a repo. Yeah, at work, obviously, we use branches all the time because the team is so big, but locally, I don't use branches ever. In this case, that stuff that I threw out, it probably would have helped to be able to just jump back. But in the process of doing all that stuff, a lot of different parts of the parser got overcomplicated. They got more complicated trying to support this thing. But it also, those parts got more robust at the same time. So it wasn't totally wasted work, because now the parser is in a much better place than it was, even though I stripped all that other stuff out. So in that case, I probably wouldn't have wanted to just jump back. But, you know, I could have made those improvements to the parser without doing all that work too. So, yeah, you know, it's trade-offs. But yeah, you have a good night too. I really appreciate you watching and being so engaged. So, I really appreciate it. And yeah, have a good night. And I hope to see you around more. Take it easy.